Hi, welcome to the presentation. Thank you for joining us today. My name is Wade Anderson. I'm a Product Specialist Sales Manager for Okuma America based here in Charlotte, North Carolina. Today I'm going to spend a few minutes and give you a general overview of our newest automation product that we've called the ARMROID. The ARMROID series is our next generation robotic system that is designed and built exclusively by Okuma to be integrated into the machine tool itself and utilizes an advanced control software that combines with our collision avoidance software to generate all of its own motion path to loading and unloading the machine. The general concept of the automation itself is really meant for the job shop type markets or people that are entering into automated processes, but they don't have the staff available to be able to integrate robots on the floor, to program or teach robots all the machine movements. For us, we wanted something that could come together as a kitted unit. So no different than buying just a turret lathe by itself. You should be able to buy a turret lathe and a robot that is all integrated together as one unit that utilizes the same software and is integrated as part of the machine tool itself. So you don't need special operators or special programmers to be able to utilize the automation. So this is an example of a turret lathe, or LB3000, where you can see the robot is truly integrated inside the machine itself. So the robot, instead of being a floor-mounted robot, picking up parts and reaching into the machine, it is integrated as part of the machine itself, and it's just reaching out to the door, grabbing the part, loading and unloading the chuck. So it's really meant to address a common phrase that we hear: I'd sure love to have a new piece of equipment. I'd love to have some automation on my floor. I just need it to come with the operator itself. Well, this gives us a way to address that. We provide a machine that has its own operator to give you the unattended, unmanned operation hours. So we don't only provide this on turret lathes, we also offer this on our multifunction, our higher tech category of lathes. So here you can see a Multus B250 with the ARMROID. This is a 5-axis machine. And again, the interesting component for me, the most powerful part of this whole system, is the fact that you don't have to have a separate programmer that knows how to program robots. This is integrated to the machine. It uses its own software to be able to create all of its own motion path to get in and out from the load position and through the machine environment utilizing our collision avoidance software. So the ARMROID is available in a few different models. We have the A101, which is primarily meant for shaft work. This is a 5 kilogram work capacity and comes with a parallel gripper. So just a 2-jaw gripper to be able to grab shaft parts to load and unload the machine. When you get into heavier work pieces, we offer a A201, and this can be configured with either parallel grippers for shaft work, again for 10 kilogram work, or we could do a 3-jaw hand to be able to do chucker work. So if you're doing round blanks, for an example, instead of shafts, doing chuck work, we can put the 3-jaw hand and be able to load, unload the machine that way. The A101 robot comes with 3 different types of end effectors. It has the 2-jaw shaft work component. So this is your end effector that would load and unload the work pieces. It has some additional added value features such as the coolant wand. So the coolant nozzle would actually follow the cut to help from the chip cutting standpoint to keep stringers from building up, things of that nature. Or we have a workpiece support that could be utilized. This is a dual roller support mechanism that the ARMROID can use to give a little bit of damping characteristics to the cut itself. So if you're doing long shaft work, for an example, instead of utilizing a steady rest, we could put a work support system behind it to give it a little bit more support to eliminate chatter during the cut. In this example, we're showing one of the workpiece stalkers. So this is a system that would have 4 different racks. 2 would be inbound to the machine, 2 would be outbound for finished goods. The ARMROID type A201 is offered with either a 2-jaw shaft work end effector or a 3-jaw flange work. So if you're doing, again, chucker work, for an example, This would be where we utilize a 3-jaw chuck to grab the parts, load in and out of the machine tool. We still offer the coolant wand as well as the workpiece support system. In this example, we're seeing the stalker table. So this is a traditional stalker table where you're loading up your blanks and it's feeding up the blanks to the pickoff position for the robot itself. This is a very similar system if you're familiar with any of our high-speed gantries or twin spindle forward-facing lathes that are running high-speed gantries. This is the same type of stalker mechanism that would be used on those type of inbound and outbound stalkers. This is an example of a couple of different types of stalkers that are available depending on what your work scenario is. So a 2-step type, this would be utilized for typically 12 blanks with a nominal diameter of around 25 millimeters. So this gives you 12 blanks going in with 12 coming out. Then we step up to a 4-step system, which would go up to 20 blanks, again utilizing a nominal diameter of about 25 millimeters. And then a pitch feed conveyor. So if you're using larger diameter work pieces, for an example, this may be a time where you'd want to look at a pitch feed system instead. Then we have the flange type stalker, again for your blanks, your chucker type works where you're slugging material and stacking them up. Each one of these systems would offer different lengths of runtime depending on the type of work that you're doing. Obviously, the approximate runtimes here are just nominal runtimes based on the same type of part or same type of cutting. Your particular part, your cycle times obviously are going to dictate the amount of runtime you would get in an unmanned operation. This is a quick overview again of the different types of end effectors. So starting with obviously the workpiece gripper. So that's the grippers that you're going to use to get the parts in and out of the machine tool itself. The work support, if you're doing shaft work, anything where you're wanting to add a little bit of damping to your cut. In-process chip cleaning. This is such an important component. Even if you don't need it for the cut itself to follow the cut, utilizing it to clean the inside of the machine, just to get some of the nooks and crannies that sometimes shower coolant or things don't pick up. Any type of accumulation buildup could create problems down the road. This is another tool that you could utilize to help clean that without an operator having to intervene. And then you can see the end effector stalker itself. This is a drawer system that comes out from the firewall that stores all the different end effectors. So one thing to keep in mind as we're watching the movement of that robot, again, is you don't have to program any of that movement. It looks at collision avoidance software and the units that you're wanting to pick up as well as the load position that's been defined, and it creates its own path through there, so you don't have to have that programmer that goes in and teaches the robot where to go. The work support, again, this is a dual roller type system that's basically like a spring-loaded tensioner, and it's meant to just give some suppression to chatter for the cut itself. So this is a good example, just showing one with and one without the work support. So you can see the one without work support on that shoulder. for whatever reason, there's some chatter being built up. Once that chatter starts, it's hard to press it from that point, versus the one with the work support. So again, just breaking up some of the harmonics that feed into chatter, utilizing, again, a little bit of an added value tool from the ARMROID. So I'm trying not to talk over the top of the videos as they're playing, but here you can see an accumulation of the bird nest chips from the shaft cut that was taking place with no coolant following the cut, versus doing the same cut utilizing the coolant nozzle to follow the cut itself to help break up the chips throughout the cut and keep those strainers from forming that could eventually create problems in an automated type environment. Again, the programming of this, it utilizes the collision avoidance software, the machine tool itself, to navigate its way through the machine. So I keep repeating it, but you don't have to teach it how to get to and from the load positions. By utilizing the collision avoidance software, though, it gives us the added value of being able to catch interference points before it happens. So again, this is just another user-friendly function of utilizing the collision avoidance software that it needs anyway to be able to find its path, to help you from a setup standpoint to realize, hey, the tool that you've got isn't going to clear that cut as you're coming across that part when you've engaged that work support system. The ARMROID can be utilized in a lights out production method, or you can park it in its home position, slide the stalker out of the way, and still be able to run it in a manual type loading and unloading system. So there's times you may want to, maybe you have an operator on first shift and he's going to run parts all throughout first shift, but then you want to slide the unit back or engage the unit back and run it in a lights out system on second, or get some third shift type hours out of it. The stalker table's on wheels. You pull a pin, it's on a guide rail to the front of the machine, you slide it out of the way, the operator has full access to the front of the machine, just as he or she would without any type of automation. But then again, when you want to get that lights out or unmanned operation, slide it back in place and start your automated type processes from that point on. As far as interacting, the little bit of programming or setup that you have to do for the ARMROID itself, again, it's integrated to the OSP control. So the look and feel, being able to navigate the screens, it's the same as what you would see on your traditional type programming that you would do. All of the different functions that you would utilize the robot for are laid out in a very user-friendly fashion, very similar to IGF for an example. So whether you're loading, unloading the part, flipping the part, washing it, things of that nature, there's navigation guides that you step through. All the folders are laid out in a very convenient fashion. There's a navigation screen that's a conversational window that you utilize to be able to tell the robot where you want to pick the part up. Maybe you have a heavy mass on one end of it, so you need to move the robot closer to where that heavier piece is to grip it. You would define some of those points in this conversational window and where you're wanting to load on the chuck itself. And then from that point on, again, the motion is handled by the robot itself. You don't have to teach any of those motion paths. So thank you for your time today and joining us for this presentation. Again, this was really meant to be a general overview of the ARMROID itself and to share some insights on what it does, how it functions, and where its strengths are. We would really welcome the opportunity to be able to talk to you about your individual needs and help decide whether or not the ARMROID could be a good solution for your manufacturing process, or some of the other ways that we automate machines and other automation products that we offer could be a better fit. Feel free to reach out to your local distributor, and we look forward to working with you in the future. Thanks again.